Okay, hello Cloud Gurus. Well, congratulations. You are at the end of the VPC section of the course. This is by far the hardest section, so congratulations, you've made it. Hopefully you've learned a lot. I seriously would not contemplate going and doing the exam if you do not know how to build out a VPC from memory, so please do go ahead and do it yourself and try and do it without watching my videos. Once you can do it from memory, you're pretty much ready to take the exam. You're going to nail all the networking questions. So what did we learn? Well, what did we start out by building? We built out this. So we built out a private VPC. We built out a custom VPC with a public and private subnet. We had our instances in our private subnet that could get internet access via the NAT gateway. We had a bunch of different route tables. Remember our default route table, we didn't want to have a public route out to our internet gateway. The reason for that is when we provision new subnets by default, they're always going to be associated with our default route table. Instead, what we want to do is create a new route table and basically put a route out using the internet gateway, and then basically we go in and every subnet that we want to make public we would associate with that route table. Moving on to NAT instances, so when creating a NAT instance, remember to disable your source and destination check on the instance. NAT instances must always be in a public subnet. There must always be a route out of the private subnet to the NAT instance in order for this to work, and the amount of traffic that NAT instance supports depends on the instance size. If you're bottlenecking, you just need to increase the instance size, and you can create highly available NAT instances using auto-scaling groups, multiple subnets in multiple availability zones, and a script to automate failure. To be honest, it's a pain. Why would you do that when you could use NAT gateways? And NAT instances are always behind a security group, whereas NAT gateways are preferred by the enterprise. They scale up automatically to 10 gigabits per second. There's no need to patch or do antivirus. They're not associated with security groups. They all are automatically assigned a public IP address. Remember to update your route tables when you provision a NAT gateway. Don't forget it can take about 10 or 15 minutes, and you get that little thing saying update your route tables immediately when you provision it. You still have to wait a while before you can actually go in and update your route tables, and there's no need to disable source destination checks on NAT gateways. And it's more secure than a NAT instance because you don't have to go in and patch it. Amazon take care of it all for you. Moving on to direct connect gateways, just remember that if you've got your own on-prem data center over here, and then you have your VPC, which is say in US East 1 in Northern Virginia, and you want a reliable, steady, and secure connection, so you decide to get AWS Direct Connect, and then you open up another VPC in another region, so maybe US West 1 in Northern California. You don't need to then provision another direct connect connection all the way over to California. You can go across AWS's own backbone private network using Direct Connect Gateway. So you just provision a Direct Connect Gateway, it's here, Direct Connect Gateway, and then what you need to do is just update your route table pointing to Direct Connect Gateway for that particular route. So bear that in mind going into your exam as well. Moving on to network access control list. So your VPC automatically comes with a default network access control list, and by default it always allows all outbound and inbound traffic. You can then go and create your own custom network access control list. By default, each custom network access control list denies all outbound and inbound traffic until you go in and add your own rules. Each subnet in your VPC must be associated with a network access control list. If you don't explicitly associate a subnet with a network access control list, the subnet is automatically associated with the default network access control list, and you can associate a network access control list with multiple subnets. However, in vice versa, you can't have a subnet that's associated with multiple network access control lists. It can only be associated with one. When you associate a network access control list with a subnet, the previous association will be removed. Network access control lists contain a numbered list of rules, and they're evaluated in order, starting with the lowest number rule first. So if you do get a question on your exam, a scenario-based question, you've got a bunch of different knackles and you have to say, how the traffic is going to work, start with the lowest rule first and then work your way up. Network access control lists have separate inbound and outbound rules, and each rule can either allow or deny traffic. And for this reason, they're stateless. So responses to inbound traffic are then subject to the rules for outbound traffic and vice versa. It's not like security groups where you can just go in and open port 80 and it suddenly works. You have to do it on both sides. And you can also block IP addresses using your network access control list. You can't block IP addresses using security groups. Application load balancers, we basically just learned that you would need at least 2 public subnets in order to deploy an application load balancer. Moving on to CIDR calculations, we didn't really cover how the in-depths of CIDR calculations because we do cover that in the advanced networking specialty. Really what you need to remember is just the maximum size for a subnet for a VPC is /16. The minimum size for a subnet for a VPC is /28. So between /16 /28, always start as /24. That's basically a standard. That will give you 256 IP addresses. Then you basically, as you move up, so /25 will be half of that, so 128, so 256 divided by 2. 128 divided by 2 is 64, which is a /26. 64 divided by 2 is 32, which is /27. And then 32 divided by 2 is 16, which is a /28. You're going to get scenario-based questions where it's saying you've got 30 devices, 28 devices, 15 devices, whatever. What's the smallest subnet that you can have? Basically, you take the number of devices and then you try and get a subnet that's greater than that. But you always have to take away 5 because Amazon reserves 5, or reserves 4 addresses, but then you've got your broadcast address. So /24, 256 take 5 is 251, /25 is 128 take 5, that's 123, 64 take 5 is 59, so that's a /26. 32 take 5 is 27, so that's a /27, and then 16 take 5 is 11, and so that's a /28. So remember that going into your exam. That will definitely pick you up a couple of marks. We then went on to learn about VPC flow logs. Basically, these are logs that enable monitoring of all network traffic across our Elastic network interfaces. You cannot enable flow logs for VPCs that appeared with your VPC unless the peering is done in the same account. You can't tag a flow log, and after you've created a flow log, you can't go in and change its configuration. So for example, you can't associate it with a different IAM role with the flow log. Remember that not all IP traffic is monitored, so traffic generated by instances when they contact the Amazon DNS server is not monitored. Traffic generated by Windows instances when they go in for license activation is not monitored. Traffic to and from your instance metadata calls is not monitored. DHCP traffic and traffic to the reserved IP address for the default VCP router is also not monitored. We then went on to VPC endpoints. So originally we had this setup where our instance in our private security in our private subnet wanted to communicate to S3. It could do that via the NAT gateway, but it was sending information out across the internet. We then created a S3 endpoint. It was actually a gateway inside our private subnet. Remember that these endpoints can either be gateways or interfaces. Gateways are much more resilient and durable because they're not relying on just a single ENI, but an interface relies on a single ENI. And we then sent some, I've forgotten what we sent. I think it was some keys or something along to S3, from that instance. So that is it for the VPC section of the course. I hope you have learned a lot and had lots of fun. Remember to build out a VPC from memory before you go and do your exams, and feel free to move on to the next section. Thank you.